Alrighty, in this video we're going to go ahead and put together the mechanics for the player actually being able to shoot a projectile. Then we're going to have our pathed projectiles implement I take damage so that they can, they can be destroyed by the player's microphones, which I don't know why a microphone would destroy a buzzsaw, but this is our game and we do what we want. So let's go ahead and jump into our player and make the modifications that we have to do for his firing of projectiles. Now, first of all, we'll need to indicate on our player a transform of where we want the projectiles to be shot from. We should go ahead and, well, no, I'm not going to worry about creating we could create a particle effect for when the player shoots the projectile. Maybe we'll do that, maybe we won't. And then we also need to indicate what projectile is going to be shot from the player, and we also need to indicate how fast the player can shoot. So let's do that. Up here on the top of player, I'm going to add public game object projectile. So that's going to be the reference to the prefab that represents the projectile that the player can fire. Now, I'm doing a public game object here, but what would actually be better to do is to do a public projectile. And this is an example of what I was talking about before, where we can have a public reference to a base type as long as that base type implements mono behavior, and then we'll only be able to place objects that have a component that inherits from that base type into this property or into this field. Next up, we need to do a public float fire rate. That's how many shots per second, or what's his cooldown after he fires. Now finally, all we have to do is, as far as data goes, is do a private float can fire in. Now the can fire in will track if the player can fire yet. Alrighty. So let's go ahead and scroll down to our update method. We're going to make one modification to our update method. At the top of the method, we're going to say can fire in minus equals time.delta time. So every time we update, we'll set the can fire in a little bit smaller until it reaches 0, which will indicate to our code that the player can shoot again. Alrighty, so then let's go ahead and work on our handle input method. And scroll all the way down to our handle input method, which is down here. Here at the bottom of the handle input method, I'm going to say if input.getMouseButton down 0, indicating that the player has clicked the left mouse button, I'm going to say fire projectile, which is a method we haven't written yet. So underneath this method, I'm going to implement fire projectile. So I'm going to say private void fire projectile. And this method is simply going to be responsible for A, determining if we can fire a projectile, and then B, determining the direction that we should shoot the projectile in, and then C, instantiate the projectile, D, initialize it, and finally, last, we reset our can fire into our fire rate. So let's go ahead and do that. I'm going to say if can fire in is greater than 0, then return, because we can't fire anything at this point. Then let's determine our direction. I'm going to say var direction equals is facing right, vector 2 dot right, otherwise negative vector 2 dot right. Then I'm going to instantiate the projectile. I'm going to say var projectile equals cast to projectile instantiate projectile, which again, our projectile is our public field that represents the prefab. Then I'm going to pass in the transform of where the projectile needs to be instantiated from, which we haven't done that quite yet. We haven't added that public field yet, but we will here momentarily. So I'll say, let's go ahead and say projectile fire location dot position, and projectile fire location will be the transform of where the projectiles are shot from. And then I'll say projectile fire location dot rotation for the rotation. Once we've instantiated the projectile, we can initialize it. So let's say projectile.initialize, and we're going to pass in the owner of our game object, because our player was the person who instantiated this. We'll pass in our direction, and then we'll pass in the initial velocity of controller.velocity, indicating how fast the player is going. Then I'm going to reset our canFireIn to fire rate. Okay, so the last thing that we need to do to implement this functionality for our player is write in our projectile fire location parameter, which again will be a public field on our player that tells the system where the projectiles are spawned from. For example, if we want the microphones to go out of his mouth, or do we want the projectiles to go out of his hands? So let's go ahead and scroll all the way back up to the top of the file. And I'm going to add a public transform. Then I'm going to remind myself what I called this. Projectile fire location. So we definitely need that transform in there, as well as our fire rate and our projectile. Okay, so that's actually all we need to do in order to implement projectiles firing from the player inside of code. So let's jump into Unity and put our projectiles together. So what does the player shoot again? I need to remind myself what it is the player shoots. The player shoots the microphones. Derp. So those are going to be these little microphone guys at the bottom right. The microphone of mass destruction, which I misspelled mass somehow. We'll go ahead and correct that mistake and hit apply. So yeah, we have the microphone of mass destruction. So let's come back into our scene view and drop in a microphone of mass destruction. So I'm going to come up here to textures, texture atlas main, locate my microphone, and then dump it in there. I'm going to move this onto my player, and then I'm going to scale it up a little bit, because I think it should be scaled a little bit bigger than that, don't you think?
Yeah, a little bit bigger than that.
Like that? I think that looks good.
Maybe just a hair bigger. We can overdo it.
Okay. Well, it is a microphone of mass destruction after all.
Yeah.
Okay.
I like that.
All right, sweet. So that's our microphone. Let's go ahead and move it off to the side so that we can work on it, and then we'll turn it into a prefab. So what do we need to do to turn this into a projectile? Well, we need to type in, or we simply need to add a component, simple projectile. Now we need to set its speed. What is the speed going to be? Let's set its speed to 15, and then we can modify that later if we want to. Let's set the damage that the microphone gives to 10. For the destroyed effect, we can go down here to prefabs, effects. Let's just do a small red burst for the destroyed effect. Or no, let's do a small blue burst. So I'm going to drag out here this small red burst onto our scene view. I'm going to come up here to game object and say break prefab instance. And then I'm going to rename it to small blue burst instead of small red burst. And then I'm going to scroll down to my color over lifetime. Click on this, change it from this reddish color to a bluish color, and then change the right value from a reddish color to another bluish color. Close out of that, hit simulate, and I think that looks good, and I think it goes well with the microphone itself. We might want to make it a little bit bigger though, so maybe set its start size to 2. There we go. I think that looks good. So let's go ahead and prefabify it. So I'm going to click and drag from the hierarchy all the way into my effects folder and drop it in there. And then I'm going to delete the object out of my scene view because again, I just brought it into my scene view to create it, to turn it into a prefab. Then I'm going to scroll all the way back down to our microphone of mass destruction and bring our blue burst, click and drag it onto our destroyed effect. So we now have our small blue burst as our destroyed effect. For our points to give to player, we will leave that at 0. The player won't receive any points for the microphone being destroyed. Its time to live, let's just give it 10 seconds. So a projectile can last for 10 seconds before it gets destroyed. Now we have our collision mask to deal with. So we haven't really talked about how we were going to do this, but what we want is we want to have all of our platforms be put onto our collision mask. And actually, I really think that's about it. The only thing we really need to collide with are things that the player would collide with. So let's go into our collision mask and set platforms. But since we implemented this as a collision mask, we have a lot of more flexibility as far as what we might want to do later in terms of the projectile colliding with something. Actually, I just reminded myself, we want to do platforms, but we also want the projectile to collide with other projectiles. So how do we do that? Well, let's go ahead and create a new layer, assign this projectile to the projectile layer, and then set its collision mask to include projectiles. So I'm going to come up here to my layers menu. I'm going to hit edit layers. I'm going to see my layers right here, make sure my layers is open and not my sorting layers. And then on user layer 10, I'm going to create projectiles and hit enter. Now that I have that, I need to do two more things to my microphone of mass destruction. I'm going to need to come up here to my layer at the top and set it to projectiles. Then I'm going to need to include the projectiles collision mask. So now our projectiles will collide with platforms and other projectiles. Finally, the last thing I need to do is actually add a collider to my projectile so that it knows when it's colliding with something. So I'm going to say add component, and I'm going to add a box collider 2D to it, not normal box collider, just a box collider 2D. I'm going to set is trigger equals true. And then, because this is not a static collider, I will have to add a rigid body 2D to it. And I'll set its is kinematic field to true. So this will allow Unity to properly simulate the collision detection of this object because it requires a little bit of more calculations to simulate this object's collision because it's moving, and it's actually moving fairly quickly. So I definitely want to add a kinematic rigid body to it. Okay, so that is our microphone of mass destruction. Let's go ahead and prefabify it into our projectiles folder. So I'm going to click and drag over here into our projectiles folder and drop it. And then I'm going to delete this object out of our hierarchy because we don't want it to appear in our hierarchy anymore. We simply want to have it as a prefab. So I'm going to delete it. Now what I need to do is I need to come in here to my player, and I need to, first of all, I need to add where I want the projectiles to shoot from. So I want to add a new empty game object that represents a transform, and then I want to have that game object be parented to player. So I'm going to go up to game object, create empty. I'm going to call this, let's just call this projectile spawn. And then I'm going to click and drag this game object called projectile spawn all the way up so that that's in player. Now what I can do is I can place this where I want the projectiles to spawn from. In this case, let's have it spawn from his hand. In fact, since we're going to be animating his hand in the future, we can actually go ahead and, that's his right hand. We can actually parent or child the projectile spawn to his right hand so that it'll always move with the right hand, which is really cool because when we animate his right hand, the projectiles will always shoot from his right hand no matter where his right hand is. Now we need to go into our player and we need to set our projectile fire location, our fire rate, and our projectile. Now our projectile fire location is going to be our projectile spawn, so I'm going to click and drag that onto that transform. The projectile will be the microphone of mass destruction, which we'll click and drag onto our projectile. And that should be all we need to do. So now we just have to hit apply so that those changes are going to be applied to all instances of the player, either current or future. All right, so now that we have that all done, let's go ahead and test this out. I'm going to hit play, and watch what happens. I can now fire really, 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 really fast. Whoa.
That's awesome.
Okay, so we'll notice a couple things. First of all, we have a mistake in the the movement of our projectiles. Notice when I move, I start shooting them really, really fast. We also have a mistake with our projectiles rotation or scaling. Notice how when we shoot out our projectiles, they're backwards if we're shooting from left to right as opposed to right to left. And you'll notice that we forgot to set our fire rate, so I can just sit here and shoot out projectiles as much as I want, and none of that's constrained. So let's go ahead and fix the obvious ones. I'll first fix the one with the players being able to shoot as many as he wants. So we'll hit stop. We will go into the player script. We'll change the fire rate to, let's say, 0.5. Let's see if that works for us. Yeah, I think that works all right. I want to make sure that that doesn't, yeah, it's not colliding with the star, which is exactly what we want. Okay, sweet. Now that I've done that, let's go ahead and set the scale of the projectile depending on which way the player is facing. So I'm going to close out of Unity. I'm going to come back into Visual Studio. I'm going to be in the player script because that's what I want to modify. And then I want to scroll all the way down to the fire projectile method. And then what I want to do is I want to say projectile dot transform dot local scale equals new vector 3. And then I'm going to say is facing right, set it to 1. Otherwise set it to -1 in the x-axis. Then I want to set the y and the z to a scale of 1. So this should make the microphone look like it's shooting out from the left or the right, depending on if the player was facing left or right when he shot the projectile. So let's come back to and actually, let's not do it like this. I just realized we could do it like this, and this would be a very simple implementation, but there's actually a much better implementation that we could use. If I delete this code right here, and I open up my simple projectile, or sorry, my normal projectile, my base projectile class, what I can do is up here on the initialize method of my projectile base class, I can say transform.forward equals direction. Not only will this handle the cases where the player is facing left or right, but it'll also make the projectile properly orient itself even if the player is shooting diagonally, which this solution is considerably more flexible and now has been applied to all of the projectiles in the game. So coming back into Unity, we should see that working now. So if I shoot to the right, okay, well, we're seeing a case of, okay, so let's go ahead and hit pause. Let's take off the 2D mode, and what we're seeing is a case of our 2D stuff not working the way that we wanted it to. Look at the way that it's orienting the forward of our projectile. It's actually changing the Z rotation of the projectile, or sorry, the Y rotation of the projectile, when in reality, I want the Y to stay the same, and I really just want to set the Z rotation of the projectile to either forwards or backwards. I want to flip it up or down depending on the Z axis. So that means instead of setting the projectile's forward property on his transform, we should set his, let's set his up direction to the direction that was passed in. So let's come back into Unity and hit play. And that wasn't what we wanted either. We wanted the right. Derp. Anyway, at least we can now see the different things we can set the transform to. We can set its up, right, or forward, which is really cool. So setting its right will indeed set the rotation properly. So now as you see, I'm shooting to the left, it'll shoot to the left. If I'm shooting to the right, it'll shoot to the right. Okay, so now we're also running into a case where our velocity is causing an issue. So let's go ahead and fix that real fast. To fix that, all we gotta do is jump back into Visual Studio, locate our simple projectile script, and I'm gonna modify the way in which we translate. See, right now what we're doing, I kind of messed up here. We are actually, we're adding the initial velocity x to our direction and then scaling it by speed and delta time, and that's not going to really work because we don't want to scale our initial velocity x by speed. So we kind of want to do that calculation a little bit differently. So let's go ahead and instead do transform.translate, and I'll delete the line above this in here in a moment, but for now, let's just do transform.translate. We're going to pass in direction times, and then 2 bits of parentheses. We'll do mathf dot absolute value of initial velocity dot x plus speed times time dot delta time. And most importantly, we want to translate in space.world. And we want to do that because we're changing the transform, we're changing the rotation of our object in our base projectile script. And what we're expressing here is how to do the translation in absolute terms rather than terms that are relative to the orientation of the object that we're translating. So let's go ahead and remove that first line. Now that we have the correct line, come back into Unity, hit play, and we see that we do indeed get proper projectile spawning. Okay, so the last big thing I want to do in this video is to go ahead and make these little projectile guys, these path projectiles. I want to make them take damage. In addition, I also want to have them give points to the player when he shoots them. So let's go ahead and close out of this, come back into Visual Studio, and I'm going to locate my path to projectile script. And in order for him to be blown up by the projectile that we have, what I need to do is I need to have this implement I take damage, which will require us to implement the take damage method. Then what I'm going to do is I'm going to say basically just if destroy effect does not equal null, instantiate destroy effect transform.position, transform.rotation, and then I want to destroy our game object. So this will just destroy our game object. Then I want to award points to the player if the object that we hit is the player. But remember, the object that we're going to receive is actually the projectile, not the player. So we have to say var projectile equals instigator get component projectile. If projectile equals null, or sorry, if projectile does not equal null, and projectile.owner.getComponentPlayer does not equal null, and points to give player does not equal 0, then we want to say game manager instance add points, points to give player, and then we also want to say floating text dot show plus, or sorry, string dot format plus placeholder plus placeholder explanation point, passing in our points to give player as our parameter for that string format, passing in a style of, let's do that, let's just use point star again. So let's say point star text as our style, and then a text positioner from world point text positioner, passing in transform position, and then, or sorry, passing in camera main transform dot position, time to live of 1.5f, and speed 50 pixels a second. Of course, the last thing we need to do is we need to implement our points to give player. So by coming up here all the way to the top, after our destroy effect, I'll say public int points to give player, and we'll default that to 0, but I will be able to override this for particular pathed projectiles. Okay, so now we have all that implemented. Let's go ahead and exit full screen, jump back into Unity, and let's locate our path projectile red saw, find his path projectile script, and say points to give to player. Let's give him 5 points if he shoots one of these guys. Now let's hit play and see if our projectiles work. So I'm going to let this cannon shoot one guy, and we see that nothing happens. The reason nothing happens is I never put the path projectile on the projectile layer. So remember, our player projectiles are very restrictive in what they collide with. I have to be explicit about adding certain objects to the appropriate layers. So I'm going to come up here to layer and I'm going to say projectiles, putting the path projectile on the projectiles layer. Hit play, wait for the cannon to shoot something, and now you see that they do indeed get destroyed. We see both of our objects get destroyed, which is exactly what we want. And we also see that we get awarded 5 points every time we kill one of these projectiles. And I think that's really cool. Alrighty. This is actually looking pretty good now. The one thing I do want to do, though, is let's go ahead and... I said we might do this earlier, but I always knew that I was going to do this. I really want a nice little particle effect on our player when he spawns one of his microphones of mass destruction. You knew I was going to do this too.
I knew it was coming.
Yeah, you knew this was going to happen. Okay, so let's go ahead and create that particle effect. I'm going to base it off of effects. Let's base it off of medium black burst. And then scroll in, hit simulate. I like that, but I want to add some color to it because the microphone is bluish, isn't it? So let's bring in some color here.
Yeah, it's based off of a blue metallic.
All right, so let's give it a nice little bluish color. And then let's do random between two gradients, having another bluish color, a little bit deeper blue. And then let's also have it, let's say the velocity over lifetime, let's set it to a positive x value of something like 5 maybe? Oh, that looks good. Maybe scroll it down just a tad. Maybe 1 point. There we go. And then let's set its gravity multiplier to 1. No, let's set its gravity multiplier to 0.5. That looks good. Now let's see how big this looks in relation to the player. So I'm going to bring this over to the player because I think this might be a little bit too big. No, actually, that looks perfect. Okay, I really like that. Except maybe the color over lifetime, instead of that deeper blue, we can do a very darkish black bluish color. There we go. And then let's go ahead and come up here to game object and say break prefab instance. And then let's call this a medium blue and black burst. Then let's click medium blue and black burst over to effects, prefabify into effects, and then delete it. Now, what code do we need to add in order to make that effect happen? Well, really, all we need to do is go onto our player and add in a new projectile shooting effect and then place it in there. An alternate solution would be to go onto the projectile and actually added a parameter indicating what effect we want to play when the projectile is instantiated, but I kind of want to do it from the player's perspective in this case. So let's jump back into Visual Studio. Let's locate our player script, wherever he ran off to. And then let's add a new public field, and I'm going to say public game object fire projectile effect. And that's just going to be a new public game object fire projectile effect. Let's scroll all the way down to our fire projectile method. When we perform our fire projectile method, I want to say if, well, let's go ahead and do it at the top. I think that'll look a little bit better. I'm going to say if fire projectile effect does not equal null, then instantiate fire projectile effect at projectile fire location dot position and projectile fire location dot rotation. All right, so that's really all the code we need. Jumping back into Unity, we can open up our player script and see his fire projectile effect appeared, and we can just click and drag medium blue and black burst onto his fire projectile effect. Then let's go ahead and hit apply so we apply that change. Then let's hit play. There's one thing I don't like about this, and that is we still have this effect being, I believe, well, it doesn't follow the player. I don't know if that's a good thing or a bad thing. I guess it really depends on what you're going for. I think it would be better if it follows the player, so maybe we can show you guys an example of how we would go about doing that. The simplest way would just to be to make the to come back into Visual Studio, and instead of just it's straight up instantiating it and not doing anything afterwards, I'm going to add some more code, and to add some more code, obviously I have to make blocks here. I'm going to say var effect equals game object instantiate, and then I'm going to say effect.transform.parent equals transform. So I'm going to parent the effect to my player so that it'll move with the player while the player moves. All right, so that should be all I have to do. That should be it as far as coming back here and having the effect follow the player. Now it does. I guess the effect could probably be a little bit better, but I'm not going to mess around with it anymore. I think this just demonstrating that we can have the effect there. Obviously, people can go in and modify that effect to be whatever they want. All right. Well, I'm thinking this is looking pretty good as far as us being able to destroy other projectiles, and I think this really sets us up for creating a very basic AI that will use pretty much most of the stuff that we've been putting together so far in the video series to create, well, just something pretty cool. So we'll see you guys in the next video.